All right, so this question says the table shows the lifts of a Boeing 737 airplane at various speeds. We're to determine the pattern of growth that is shown in the table. Is it linear? Is it exponential? Is it quadratic? And we're going to continue to use the same method. So we want to think about how our output values are increasing, or lift is going to be our output values in this case. Are they increasing constantly by a constant rate of by addition? Is it by a growth factor, or do we notice a pattern that's going on? So when we examine this table and we look at the differences, well, if I multiply 25 by 4, I'll get 100. But if I multiply 100 by 4, I'm not going to get 225. So I know that this is not a constant growth factor. So then I have to check how much are they increasing, each value increasing by addition. And here is what we notice. From 0 to 25, that's 25. From 25 to 100, that's 75. Then 100 to 125, that's 125. 225 to 400, that's 225. 400 to 625, that's 275. 625 to 900, that's 375. 900 to 1225, that's 325. And 1225 to 1600 is 375. When we look at that, those numbers might seem really big, but then we want to continue again, like, are these output values, the rate of change, changing by a constant value, by adding a constant value? And so, like, if we examine the difference between the rate of change, we can see that they all increase by adding the constant value of 50. What that means in this case is that the table representing the lift of the Boeing airplane is going to be one that represents quadratic growth. And we say that because the output values, even though they're not changing at a constant rate, the rate of change is changing by a constant value of plus 50. And so this table is going to represent quadratic growth. And remember, we said what quadratic growth means is that one of our terms is squared. So we know that our x term is going to be squared.